Hi all, this is Mr. Lim here again, and this is our 7th video on intermolecular forces on hydrogen bonding, so let's get started. Alright, we're going to be learning about hydrogen bonding and how to identify if a substance will have hydrogen bonding. Alright, so hydrogen bonding, what is it? Okay, so the strength of a polar bond is based on the difference of the electronegativities of the atoms within it. Okay, so we discussed this already in polar bonding and in dipole-dipole. The idea is that the stronger the electronegativity of one particular atom compared to the other, or the bigger the difference, the closer the electrons will be to the atom that is more electronegative. Okay, so if you have HF, right, and the F is much more electronegative, then the F will draw the electrons much closer to it, right, making this the positive end and making this the negative end. Okay, so we dealt with that already, but let's go on. Okay, so if the NO or F bonds with a hydrogen, then a very strong polar bond is formed. That's because NO and F are the most electronegative elements, right? And the hydrogen becomes very positively charged. So what we're going to do is we're going to identify that with a double positive for this particular hydrogen there, and a double negative for that fluorine there, all right? So it's only for NO or F because they are the most electronegative elements. Okay, so then the NO or F is very electronegative and thus be extremely negatively charged. We just said that. Okay, so the large positive and negative charge, and the charge difference, means that the two neighboring molecules with an extremely positive hydrogen and an extremely negative NO or F can form a strong electrostatic attraction, which is known as a hydrogen bond. So for all intents and purposes, the hydrogen bonding is an extreme form of dipole-dipole. All right, it will still have, all molecules of hydrogen bonding will still have dipole-dipole because, you know, it's just a positive and negative end, except when it becomes really strong, right, then it becomes called a hydrogen bond. All right, so let's move on. Okay, so a hydrogen bond to form, you must have a hydrogen bonded to an NO or F and an NO or F. Okay, so we have to remember that hydrogen bonds are intermolecular forces. So they must be between two molecules, not two atoms within one molecule, right? So the bond between the NO or F and the hydrogen within the same molecule is still a covalent bond. Okay, so looking here, if we have H2O, right, the hydrogen bond is between this hydrogen and the oxygen of another water molecule. Okay, so the hydrogen bonded to an NO or F is this one here. This hydrogen is bonded to an O, and it's between an NO or F, which is over here. So that's the bond between there. It relies on these two conditions. Number one condition, the hydrogen bonded to an oxygen here, and the number two condition, an NO or F there. All right? So hydrogen bonds are generally drawn as perpendicular lines between two molecules and drawn from the very positive hydrogen to the very negative NO or F. Okay, what I want to emphasize, and that this is something that gets a lot of students confused, is that this one here is not a H bond, not a hydrogen bond, right? This is a covalent bond. So we are not talking about intramolecular bonds, the bonds between atoms. We are talking about intermolecular bonds, which is the bonds between molecules. All right? And so, let's move on. Okay? So, hydrogen bonding, again, can contribute to the total amount of attraction between two molecules that are relatively strong compared to the two other intermolecular forces. Okay? So, remember that this idea that it contributes is key, right? It is just one part of all of the attractions of two molecules together. It can be a major part, but it's still a part of it, all right? So the strength of the hydrogen bond cannot be increased like it can for the dispersion forces and for the dipole-dipole, even though, like, you know, effectively dipole-dipole increased becomes hydrogen bonding. But the idea is that the hydrogen bonding strength cannot be increased, but you can have more than one hydrogen bond form between two molecules. all right? So you can just have more than one hydrogen bond formed between two molecules. And then, really, this is a key idea, is that not all molecules of H, N, O, and F will have hydrogen bonding, right? If you don't have the hydrogen bonded to the N, O, or F. So let's have a look at some of these examples. Okay, so let's have a look at CH2O. Okay, this is where you have to put together all of your knowledge about shapes of molecules, Lewis dot diagrams, electron dot diagrams, working out the shapes of stuff, working out stuff, all the way to work out whether this is going to have hydrogen bonding or not. Okay, so this one here, if you put this together and you draw the electron dot diagram, this is what you will end up with, okay, with the O's here and O's here. Okay, and then if I have another one of those, okay, in a trigonal planar shape, will this form hydrogen bonding here? Okay, well, we have to go back to what are the two conditions? Okay, so the two conditions are a hydrogen bonded to an NO or F and an NO or F, the two conditions here, all right? Do they have those two conditions? Well, they have the second condition, they have an oxygen here, but is this hydrogen bonded to an NO or F? No. So this is not going to be hydrogen bonding, not hydrogen bonding. Okay, but here's the tricky thing, right? Because this is between, can this never make hydrogen bonding with anything else? No. This can form hydrogen bonding with something that is bonded to an NO or F, because this is the very electronegative part, right? So a key idea is that you can have hydrogen bonding between molecules which don't have hydrogen bonding within themselves or between themselves, all right? So CH2O cannot have hydrogen bonding with itself, but it can form hydrogen bonding with other molecules because it has an NO or F, all right? And for all intents and purposes, for now, we're going to be dealing with, can the substances have hydrogen bonding with itself? But later on, we're going to be focusing on, can substances have hydrogen bonding with other substances when they dissolve, all right? So it's a key distinction to make, but the idea is that for now, we're focusing on, can it have hydrogen bonding with itself, all right? So let's have a look at this one here. Maybe let's do CH3F, all right? So can this have hydrogen bonding with itself? Okay, so if you draw this one out, it turns into this. Okay, so will this have hydrogen bonding with itself? Well, first of all, is it a polar molecule? Yes, because you can have a negative side on this side and a positive side on the other side between the three hydrogens. But the idea is that, remember, whilst you have a very negative part here, you do not have a hydrogens bonded to an NO or F. So this will not have hydrogen bonding, all right? Again, something like HCN, that's not going to have hydrogen bonding either, because again, the hydrogen isn't bonded to the N. Okay, so there's many different things that won't have hydrogen bonding, but there's lots of things that will have hydrogen bonding. All right, so CH4O. All right, the only way that this one can be drawn is like this. Okay, got the extra electrons there. So the idea is that here is my very positive hydrogen because it's bonded to an NO or F, right? And then if this thing's going to have, hydrogen bonding to another molecule, I have to think about how I'm going to draw this, right? I have to draw the O of one of those other. I have to draw this O on another molecule of this near this hydrogen. So I'll draw it over here. And then I'll draw it with a hydrogen here, bonded to the C, bonded to three other hydrogens, right? And then I can show that there is hydrogen bonding between the very electronegative oxygen here and the very electropositive hydrogen there, okay? You do not need to write out these fancy little negatives and positives. You can just show them as they are. They're just to highlight it for you, okay? So that's the idea behind that. Not all molecules with H, N, O, and F will have hydrogen bonding. So you have to be able to draw the thing and work out whether it will have hydrogen bonding or not. All right, that's it. Adios.